Good afternoon, everyone. So my name is Vishal Chaudhary, Assistant Professor in AKGEC College, Ghaziabad, Department of CSC. So my topic is greedy technique. So this comes under the design and analysis of algorithms. So in basically the algorithm design techniques, we have three techniques. First one is the divide and conquer technique, DAC. Second is greedy. Third is dynamic programming. So today we will discuss about only greedy technique. Yeah. So what all we were gonna discuss today is what is greedy. So what do you understand by greedy? Then what is greedy technique exactly? Then what is the optimization problem? Because all the problems like optimization will be solved by greedy technique. Third is the features of greedy technique. Fourth topic is the properties of greedy technique, and third is the application of this greedy technique. Now let's see what is greedy. As the name suggests, greedy, someone is who is lalchi. See, a greedy algorithm, as the name suggests, always make the choice that seems to be best at that moment. Like what greedy does, it always look for the particular best moment at particular time. Okay, as the name suggests. Now, greedy is an algorithmic paradigm that builds up a solution piece by piece. What did this mean? That it's while going towards the solution. Suppose here is a problem P. Now we are approaching towards the solution P, and here is the solution. Now we are approaching towards the solution this way, maybe this way, maybe, and a number of ways. So it always look for a optimal solution at each stage. Like here, suppose here is the one path, one more path, but this is the optimal one. After there is one more path, but this is the optimal one. So we have selected the final this particular path. So it always builds a solution piece by piece, one by one, selecting the best optimal solution. This means that it makes a locally optimal solution or a choice in the hope that this will help in leading to a globally optimal solution. What does this mean? While reaching here, we have two paths. One is this, one is this. So this is the locally optimal. While reaching here, we have two paths. This. Suppose this is also the path. So here, this is the locally optimal. But after reaching this particular solution, this is the globally optimal solution. So this is all about the greedy technique. Now, let's see a dummy algorithm for greedy algorithms. Greedy D, N. Suppose this is the weights. This is the number. Now, in greedy approach, it is a domain from where we have to select the items from which the solution is to be obtained of size n. Initially assume we haven't selected any particular item. हमने कोई item select नहीं किया है. So initially the solution array is 0. After selecting solutions from the domain one by one, we will add into the particular solution array. But initially it is 0. Now from I to n, because we have to complete n size. Now for particular loop, for loop I to n, what we have to do, select D from the domain and see if it is feasible solution. If it is a feasible solution, then add to the solution array. Initially it is 0, but now solution array have 1. For I equals to 1. Suppose for I equals to 2, it is not feasible. The solution array is still 1. For the I value 3, it is feasible. We have added in the solution array. This is the array till the third iteration, and so on. We will go till n. Now, after reaching the n, this particular array will have the final solution array. This is the algorithm for greedy algorithms. Now return solution at the end. Now, what is optimization problem? An optimization problem is the one in which you want to find not just a solution but the best solution. Suppose we have n number of solutions for a particular problem. Suppose there is a problem P which will give us 1, 2, 3 and n. These are the solutions for a problem P. So these are the solution set, but we have to find which is the optimized one. So suppose solution number 3 is the optimized one. Solution 3 is the optimized one. So this is the solution of optimization problem. An optimization problem is the one in which you want to find out not the solution but the best solution, which is the best one. A greedy algorithm sometimes works well for optimization problems, sometimes not. That's easy, okay. A greedy algorithm works in a phases at each phase. That what does it mean? It means the greedy works in two phases or two states. Like you take the best you can get right now without regard for future consequences. What it means? You will always look for the locally optimal solution or a choice which is the best for now, or you hope that by choosing a local optimum at each step you will end up at a global optimum. These are the two phases for the optimization problem. Now see, in the optimization problem, first two phases. We have two phases. First is the finding minimum optimal, which is a minimum cost, okay, and finding minimum optimal, which is the maximum job in limited time. Suppose we have to reach destination D from the source S. So there are suppose there are 5 ways to reach, 5 ways. First is this direct one, this one, 1, 2, 3, 4 and 5. So suppose this particular path 1 have a cost 30, 2 is 40, 3 is 50, 5 is 10, 4 is 20. So by looking up the automation problem, we have to find out which is giving the minimum cost. Here the particular path 4th from S to D is giving 20. No, not this one. This is one. From source to destination, this is the minimum. This is the minimum cost from S to D. And this is the path 5, which is giving the minimum value 10. So here is the example of this minimum cost, right? Now see the second example for the maximum job in limited time. Suppose we have given a jobs, n jobs here, n is 4. Suppose कीजिए 1, 2, 3 and 4, and we have a limited time. Suppose time frame is only 2 seconds. 1 second, right? So here we will select the particular job which is giving the maximum profit within the time frame only. Suppose the first job is giving 10, 2 is giving 40, this is giving 10, it is 20, 4 is giving 50. So I'll select first 4, then 2. Why so? Because we have only 2 slots, because we have only 2 seconds to perform the job, but we have the available 4 jobs. So we will select the jobs which is giving the maximum profit. Here the job 4 and job 2 is giving the maximum profit. Here it is 50 and this is 40. So the maximum profit is 90. This is an example of maximum job in limited time. So these are the 2 solutions, or like 2 approaches for optimization problem. Now, features or characteristics of greedy. Now, to construct a solution in an optimal way, or that means to construct a solution in an optimal way, algorithm maintains 2 sets. As we have already seen in the main algorithm, the first set contains the chosen items, what we are choosing, and the other one contains the rejected items. Suppose from the solution array, suppose in the domain n2, 3, 3, 4 is given. But in the solution array only we have 2 and 4. So the solution array for the rejected items is, it is 1 and 3 because these are rejected. And this is the final solution array 2 and 4. So the other contains the rejected items. Now, greedy algorithm make good local choices in the hope that they result in a optimal solution, already seen, and feasible solution. Now, greedy property. So basically greedy have 2 properties. First is the greedy choice property and second is the optimal substructure property. Now see the one by one. Greedy algorithm can be applied to problems following in 2 basic conditions. First is the greedy choice property. That means a global optimum can be reached by selecting the local optimums. Right? To reach to a particular solution, we have to select locally optimal. Suppose this is the path. We have selected this one. Now from here we have this one, but we have selected this one. These are the local optimum to, in a hope that we will get the globally optimum. Right? Now, and the next property is optimal substructure property. What it does, a problem follows optimal substructure property if the optimal solution for the problem, this is the main thing, problem can be formed on the basis of the optimal solution to its sub-problems. Right? Now, greedy applications. So basically we have n number of applications for greedy. First one is the fractional knapsack. Now, what is the knapsack problem? Knapsack basically a bag, an empty bag, and we have to fill with the items. So fractional means we can divide the items in parts. This is the fractional knapsack problem. This is the first application. Second is the job sequencing deadline. As we have already seen in the optimization problem, what is the job sequencing? We have to select the maximum job with maximum profit within a deadline only. This is the second application for this particular greedy algorithm. Third is the Huffman coding. Huffman coding. So this Huffman coding is basically a data compression technique. Technique without the loss of data. Without data loss. We will see in the examples. Now, fourth is the minimum spanning tree. Basically, spanning tree is a sub part of a graph, and there should be a no loop and with minimum cost. Minimum cost. So in this particular algorithm, we have 2 approaches to algorithms. One is the prim algorithm, second is the Kruskal algorithm. Now, this is the fifth one, single source shortest path. In the single source shortest path, we have algorithm Dijkstra. That means Suppose from a single source S to reach D destination, we have n number of paths. Suppose that here is the some C, here A, K. One is the direct path, one is from K, one is from C, K, one is from C, K, D, one is from A, D. So we have to find the single source. This is the initially single source shortest path, which is the shortest one. This, maybe this, maybe this. So we will find out by the algorithm, which is the Dijkstra algorithm. Dijkstra. Now, see the first algorithm, that is the fractional knapsack problem. So what is the problem here? There is a warehouse with n items. Suppose there is a room with n items, where the ith item has a value vi and a weight w. Suppose if I select a particular item from this particular warehouse, so there is a weight which will be coming out with some value. Now, suppose a thief enters the store. Suppose a thief enters a particular store or the room or a warehouse which has have a weight of a capacity some x. That means with a bag of capacity x. So he has to fill or the main problem is he has to fill the his bag with some capacity. Here it is 6 with the maximum profit with less weight, right? So we have given this particular weight 10, 3, 2, 1, 5, 2 and the value. Suppose if I select this particular item with weight 10, giving me the value of 1. If I select the item number 1, barley, of weight 3, which will give me a value 2. Pulses, weight 2, giving me the value of 2. If I select the weight 1, saffron, which will give me a value 6. If I select the vanilla of weight 5, which will give me a value 4. Same, clove 2, which will give me a value 3. So the thief has to fill his bag with the maximum value with minimum weight. So our main approach is, our main goal is to fill the bag with the maximum value. So this is the problem. So the goal is to find how to fill the knapsack bag so that the total items in the sack have a maximum value. What we will do, so we will the algorithm greedy will give the solution for this particular problem. Problem is a fractional knapsack problem. As the name suggests, fractional, what it is mean? It can divide the particular item in parts. Suppose this is the item number 1, so it can divide in the parts, and we will pick according to our need. Suppose I need only 2 parts, so I can pick from the 1, 2, 3, 4, 5. So 2 by 5. Now, so the approach for the particular item, problem is this greedy algorithm first compute the value per unit weight. What it means, for a suppose the weight 10 gives a 20 value. So first I will compute what is the weight for a 1 weight value. What is the value? For 1 weight equals to 20 by 10 value. So first I will compute this. So in the particular example, we have given weights, as already seen in the last slide: flour, barley, pulses, saffron, vanilla, clove, and the weights are 10, 3, 2, 1, 5, 2. Now, and the associated weights are, for flour, weight 10 value is 3, it is 2, it is 2, it is 6, 4, 3. So first what we have to compute? We have to compute values per weight. Values per weight. This is the part. This. देखिए. Now, for weight 10 giving me a value of 3. So what should be the value of 1 weight? That means for 10 weight giving me a 3 value. So what is the 1 weight value? It is 3 by 10. V by W. So it is 3 by 10. Same. For the weight, barley of weight 3 gives me a value of 2. Same pulse is 2, 2. Now, it is 2 by 3. 2 by 2 it is 1. 1 by 6 is equals to 6 by 1. It is 6, 4 by 5 and 3 by 2. This is the approach. Now, we have to sort in the descending order. That means the item which will give me a maximum value with the minimum weight will come first. We will sort this particular array. So, see, it is 3 by 10 less than 1. 2 by 3 less than 1. It is 1. It is 6. It is less than 1. It is 1.5. Now, the maximum value is this. So, it will come here. So, we have sorted in the descending order. So, it is 6, 3 by 2, 1, 4 by 5, 2 by 3, 3 by 10. Now, what we will do, we will pick one item from the leftmost item in the array, that is this 6 particular item, and we will add in the bag, and the bag capacity here it is 6, right? Now, greedily add to remove. Now, we have selected in the descending order. Now, we have to select from the leftmost item in the array. So, the bag capacity is 6 here. It is 6. Now, we have selected the first particular item, giving the value of 6. Weight 1. Maximum weight is 6. We have selected this item number 3. Weight 1. It is 6 minus 1. Now, bag is filled with the weight 1. Now, bag has a capacity of 5 and the value comes with the, it is 6. Now, next item, it is 3 by 2, item number 5. Now, the weight of item number 5 is 2. It is 5 minus 2. It is 3 left. And the value comes with the 3 here. Now bag has a bag left with the capacity 3. It is 3 minus, now third item number 2. Now it is 3. It is the weight of 2. It is 3 minus 2 equals to 1. And the weight is, value is 2. Right? Next. Now bag has a left with weight 1 or a space 1. Now next item, it is 4 by 5, fourth item. It is the weight 5, value 4. So we have already computed the one weight value, it is 4 by 5 and only 1 is left. So we will choose with the 4 by 5 and it is 1 minus 1 equals to 0. So this is the approach. Now see the fractional knapsack problem. We have a given array V, value array, weight array and an integer W. Right? From size 1 to size V, we have what we have to do. We have to calculate VIW by WI. This is the P's value. Now, after doing this value, we have to sort the array. The resulting array is P. We have sorted in the descending order. From I equals to 1, while W greater than 0, we have to what we have to do? We have to add the item in the solution array by checking the boundary condition, that is the weight of the particular knapsack. And at last, we have to return the solution. And the time complexity of greedy algorithm using the knapsack problem is the finding Pi, simply a n loop n, it is order of n. Sorting the Pi in decreasing order using the merge sort will take n log n time. While loop will take order of n time. Totally it is n plus n log n plus n. So n log n is the dominating term. N log n in every case. Here the dominating case is the sorting Using the merge sort, it is taking the n log n time. Thank you.